Yes, that. Please, thank you very much. Well, good morning, ladies and gentlemen. We've had quite a multidisciplinary morning this morning, eh? And that's multidisciplinary, this conference. We spoke about computational chemistry, and we've spoken about accounting in radiology,
Yes.
and now we speak about renewable energy. And more specifically, using the Internet of Things to try and determine the energy used, the energy wasted, really to do with remote energy monitoring. That's what we're speaking about, energy monitoring, but remotely. And we'll see why we're talking about that. Right, so I must thank the organizers too for the conference. I enjoy coming to Mauritius, thank you very much. I was here last year for a conference. We're trying to get some collaboration going with the University of Mauritius, with the electrical department there. We're meeting them again on Friday. Hopefully we can get something going, because we've been trying for a whole year. So if we don't come right, we'll come to you. And we'll come and put our equipment on your roof there. I see you've got a third floor, so you must have something higher up. Eh? So we're actually just looking for a building that's got a nice flat roof where we can put our equipment for remote monitoring. No resources you need to give. We provide everything ourselves. Yeah, oh, yes, thank you very much. So I'm glad I came to this conference too. I found another collaborator.
And we'll use computational methods to enhance the efficiency.
Oh, there you go. Excellent. You see, very good. So that's what we're going to discuss, ladies and gentlemen. I'm sure we can read. I don't need to read everything for us. And you'll see as we go along, we'll cover it all. So first of all, introduction. A lot is being done in the field of energy today, and especially in renewable energy systems with regard to simulation. Now, simulation has its place, ladies and gentlemen, but you need to also have empirical results. You need to be able to compare the two at the end of the day. You can't just have a whole lot of simulation and say, all right, this is going to work. There are many factors which cannot, or that are not at the moment, built into simulation packages. And I'll give you one example, climate change. How many simulation packages really have all the different variables built in? The amount of rainfall in one area is changing radically now. So cloud cover now impacts especially on solar and power, solar power plants. What simulation package has built that in, or has taken that into account? Because at the end of the day, a renewable energy system needs to remain sustainable. It doesn't help it goes down every 2 weeks. Then there's no use in that. So our research is really based on verifying simulation studies that have been done. So for this we need, of course, now our empirical results. Many times though we are stuck in one location. So how do we get empirical results from multiple locations? And that is where our little jig or our experiment then comes to the fore. So our context, where we first introduced it, now remember our end goal, ladies and gentlemen, is to take this jig or this project of ours and duplicate it. For instance, at University of Mauritius, we've been trying to get a research site. Our next objective is the Seychelles. We believe there's a conference next year, organized also by Seychelles. So we're going to head there, try and find a collaborator there. And then, of course, we're looking at the rest of Africa too, Gaborone and Namibia also. Trying to find research sites where we can put of course, you might say, yeah, but there's global weather data that is available from these sites that can be put into simulation packages, which is true. However, again, ladies and gentlemen, a weather station can only provide you with so much input. For instance, a weather station is not going to look at the effects of a pigeon on a PV module. It's not going to give you that effect. Where with our little jig, we can get those effects too. We can get the effects of dust on a PV module. We can get the effects of severe clouding or even tree shading that comes to the fore, which a global or a very high-tech weather station is not going to provide for you. So you see, these are variables. You might think it's a small variable, but at the end of the day, all these variables add up and impact on the sustainability of a renewable energy system. So this is our research site. It's in the middle, Bloemfontein, middle of the Free State. We have a lot of pigeons in our area. On average, about 3 to 4 pigeons sit per day on a PV module. And remember, ladies and gentlemen, it's not just the shading of the PV module, it's what the pigeon leaves behind, which also creates problems. And just one cell from those who are familiar with solar modules, just one cell, if you say shade just one cell in a big PV module, you decrease the efficiency of that module immediately.